So everyone is interested in SBOMs? I was actually, didn't think anyone was going to show up to this. I was a little worried. And then they put me in this room and I was leaving a little more worried. So most of us have heard of SBOMs, I guess. Who has been told they need to worry about SBOMs? A few folks, a few of your bosses came to you and said, we need to do something. All right, we'll get into that. All right, so I'm going to talk about what SBOMs are. We're going to talk a little bit about how to create them. There's a bunch of different ways. I'm going to give you a couple really short demo, and then we'll talk about some common problems and some solutions, and hopefully what you can do to improve kind of your the security of your applications. So first up is me. So I'm Brian Demers. I'm a developer advocate at Gradle. I've spent most of my career kind of in and around open source communities, kind of in the areas of build tooling and security. And a lot of times those seem kind of different, like different ends of the spectrum. But then you talk about a topic like SBOMs, and I'm going to create them in my build, so they're a little more related, right? Outside of all this, I keep bees in New Hampshire. So I live a couple hours north of Boston in the States, and I get stung all the time. All right, so if you haven't seen one of my talks in the last couple of years, I like to start off with this little game, right? So if you have not seen this episode of Silicon Valley, you can Google this clip. It is amazing. Just tabs and spaces, Silicon Valley, and you will find this clip, and you will laugh for the next 10 minutes. All right, so raise your hand if you're a fan of tabs. All right, this is an interactive presentation here. All right, spaces? Spaces have it. I'm going to go with spaces anyway, so spaces have it. All right, this is a little more polarizing. Dogs? Oh no, come on. Cats? All right. I'm allergic to cats. My wife really wanted a cat. She made me get an allergy test. My arm exploded with everything. The doctor wrote me a note, said don't get a cat. So we have a dog. And he's big. This is an old picture, but he's like 50 kilos, so he's a good-sized dog. All right, and you saw this coming too, right? Anybody? So Gradle? All right, Maven. All right, Maven has it, I think. All right, so if you can see my shirt, right? I talked about how I work at Gradle, but obviously Maven was prominently featured in my little bio slide. So why is that the case? This is not a talk about Gradle, so don't worry. But Gradle, the company, Gradle Inc., who signs my paychecks, creates Gradle Build Tool, and that's typically what we think about when we hear Gradle, right? We also have a product called Develocity. It's all about making your builds faster and making you more productive and uncovering things you might not have seen in your build before. It works with Maven, Bazel, Gradle, SBT, NPM, and Python. I didn't update my slides recently. But we like to practice developer productivity engineering, which is kind of engineering your way to faster builds and feedback. But this talk is not about that. All right, so think about how you would explain how you create a Java application to someone that's new in your company. Right? Maybe they've done a little bit of Java before, maybe they haven't. All right, so first up, you're going to install JVM, right? Then probably a build tool. We're going to install Maven. Then you're going to write some code, make sure it gets compiled, packaged, right? But we probably need to download some dependencies. Most of those dependencies are going to come from Maven Central. Great. But since you're at a company, you're probably going to have some internal packages you rely on too. So you're going to have to configure some sort of internal Maven repository in your build tool. You're probably going to want to write some tests. So there's some more dependencies, more code, right? And we haven't even talked about CI, CD, logging, or any other observability concerns, right? So in a simple word, software supply chains are complex. Complex systems have a lot of moving parts, right? And that means they're ripe to be compromised. All right, something security. All right, so this is actually a quote from one of my colleagues, and I love it. So every time we talk about anything that's vaguely security shaped, it's always something security. It's a bit oversimplified, but if you think about it, right? I've worked in the kind of the security space, application security space for a little while. That's security. But so I could talk about OAuth for the next hour. Then we could have somebody talk about vulnerabilities for the next hour. And then we could have somebody come up here and do a lockpicking demonstration in physical security, right? Those are all security. So the bucket that SBOMs fall into is probably GRC. So if you're talking to your boss, this is probably the word they might want to hear, or the words: governance, risk management, and compliance. So that's the flavor we're talking about of security. But feel free to say something security as well. All right, who eats pancakes? Everybody likes pancakes. All right. So this is a recipe. So every time you hear about SBOMs, everyone always talks about the ingredients list. So without fail, here's my recipe with my ingredients list. So I've been trying to cook a little more at home lately, so I've been following a lot of recipes. Not so much this one. I'm going to apologize for everybody. This is in freedom units, so I don't know the conversions, but I'm sure if you Google it, you'll figure it out. I hate them too. It's the fact of life. All right, but our recipes are very similar to our builds, right? We have some inputs, maybe some dependencies, and then it's a bunch of instructions to turn those dependencies and source into a jar, right? So much like I'm going to turn some flour into pancakes. Anyone vulnerable to gluten? Nobody. All right, that's good. That's good. You can all eat my pancakes. But you can take a look at this ingredients list, and you know that I'm using all-purpose flour, so you probably don't want to eat them if you have a gluten issue. All right, so SBOMs. SBOMs are basically a document, usually in JSON, but it can be in XML or any other format, that has a listing of your dependencies, of your application. I'm going to show you a few in a few minutes. But they let the people who use your application know the ingredients of your app. Multiple government and regulatory bodies are dictating you must use an SBOM, or you must provide an SBOM if you do business with them. So they essentially want to know your ingredients list. Anyone fall into those camps? Potentially if you work at a bank or do business with a government? A few folks? Yep. So this is really the main use case behind all of this is vulnerability disclosure. So if I give you a list of the components that are in my application, you can compare those against a vulnerability database and know if you're affected or not. So my story here, hopefully I won't talk about Log4Shell. I wish we could stop talking about Log4Shell, but I'll have a Log4Shell story. So a buddy of mine calls me up in the early days. So this was like day 1 or 2. In a panic, of course. He works at a small IT department in a school back in New Hampshire. And he's like, how do I know if I've used Log4j in any of my applications, right? Remember, everything essentially that used Log4j was basically vulnerable at the time. And I was like, you're out of luck. There's not much you can do about it. You can do the basic scanning. People recommended doing some basic grepping your file systems for Log4j, but I don't think that was enough. So I told him, all of the different ways that we package jars today, right? I don't know how you package jars or package your Java applications. You can have jars in a directory. You can have Uber jars, jars in jars, right? Wars, ears, shaded jars, obfuscated jars, shaded classes that are relocated inside of a jar so you don't know what the original package was. And we use native binaries too, right? So it's really difficult to do a basic scanning and find those things. So if all of his vendors gave him an SBOM, he would know what bits of software he had to worry about. He didn't have those, so he was kind of out of luck and just panicked for a few months. So that's kind of like consuming third-party applications, but if you're shipping software or shipping software to your ops team, right, it's very much the same concern. They want to know what is running, it could be affected. So potentially you're giving somebody in-house your SBOMs instead. And again, most of this is vulnerability management, but license information is already in there, right? So if you have to do some basic license compliance, you can also use an SBOM for that. All right, so I'm a Maven guy, right? So I have my dependencies in a POM, right? Why do I need another format? Right? Maybe it's because my transitive dependencies aren't in here, right? So those are the dependencies of my dependencies, but I know how to work around that. I can do some sort of effective POM or dependency tree, or I could craft something to get around that, right? But this really only works in the Maven ecosystem. So we need some sort of common format. The problem, though, anyone know what the problem is with this common format? There's a whole bunch of common formats, right? So the big two are SPDX and Cyclone DX. Anyone heard of those? Yeah. So those are the big two, but there's a bunch of other ones. So SIFT, the container and file system scanner, has its own format. Salsa Providence Doc can also contain dependency information. We'll talk about that in a little bit. The build pack folks, the Paketo, they had an SBOM format a while ago that's deprecated, but there are other formats out there. Does that sound like this? All right, so this is one of my, I don't know, maybe not my favorite XKCD, but one, it's up there. So it's frustrating, right? So converting between the formats is a bit lossy. Different tools that create the same files use different attributes in those files. It's just a pain in the butt to deal with it. So the governments and the regulatory bodies that said you need to provide SBOMs have not told us what they want for an SBOM. So you basically pick one and hope that's what your consumer wants. So this obviously is problematic. So in-house, I would say pick one. Pick your favorite and then stick with that. I'm going to show some Cyclone DX here in a few minutes. So this is a snippet. It's a little dark on this screen, but I'm going to open up my IDE in a minute and show you another one. So this is one dependency in a Cyclone DX SBOM. And I've trimmed it a little bit just to fit on the screen. The Maven plugin adds like 500 different SHA formats, so you'll see that. But there's some basic information in here. The license information, the project, the issue tracker, the Git repo, but there's also a PURL, a package URL. Anyone heard of a PURL before? A few folks. This is one of my favorite things since sliced bread. Maybe not, but so if you've ever opened a vulnerability, usually you have to figure out how to encode your package into a CPE, so the CVE databases understand how it works. Those don't fit very well into the Maven packaging structure. So someone came up with a PURL, and you can see, hopefully you can see in there, in the top there, it's PKG Maven. So that means everything to the right of that is going to be information about a Maven packaging structure. So there's also a PURL for NPM and NuGet and whatever package system you like can all be encoded in basically a URI. So it's really handy to now we can pass around one string and each packaging ecosystem knows how to deal with that. All right, so let's generate an SBOM. I'm going to struggle converting my screen here for a second, so bear with me. I walked through this several times beforehand, and every time the resolution is wrong. All right, here we go. So I have a POM file. This is a Spring Boot application, and all I've added is this plugin. Spring Boot automatically adds this. All you have to do is add the plugin, and it automatically adds the execution for you. But if you weren't using Spring Boot, of course, you need to add an execution block, right? And this is basically telling Maven, hey, I'm going to do some stuff here. Run one of my goals. So everyone complains about how verbose XML is. It really isn't that bad. Yeah, it's a lot of extra lines, but I mean, I typed it in 30 seconds, right? So this is Spring Boot, so I don't need this. Hopefully that red squiggly line goes away. What did I do? I don't know. We're going to roll the dice here. Oops.
Line 122.
122? I don't see this extra slash. Yeah. All right, let's do this, huh? Let's see what I did. Yeah, I don't know. I mean, Maven didn't run either, so something was wrong in there. All right, so this takes 15 seconds to run. I'm going to build a container image, and I'm going to scan that in a second here too. One of the cool things that Spring Boot does is they automatically configure the SBOM to be packaged inside of your jar. So there's some rough edges with that. We can talk about later if you want. But it is cool. That way, anyone who gets your jar also has your SBOM, so they know the details about it. And in my case, I think it's important to include information about my build in my SBOM, so I'm going to include test scope. Now, I'm going to talk a bit about this in a minute. All right, so let's open this thing up. So if it was in a jar, it would be meta-inf SBOM application CDX JSON. And this is a Cyclone DX JSON file, right? So I'm not going to go through this whole thing, but really briefly, there's a section here, tool. So this is the tool that created my SBOM. So this is important because if the hashes don't match what I expected, then I really can't trust the SBOM. There's probably, we could get into signing of this SBOMs too, and I'll talk about that at the end of the presentation. But this tools is what created the SBOM. Then I have my components. This is what my application is. In my case, it's a Spring Boot app that is a dice parser. So you can pass dice notation into a REST request. Everyone know what dice notation is? We're all nerds, right? Like 1d20 plus 4. You roll a d20, you add 4 to it. Okay, and actually there's a whole lot more things that you can do with dice parsing, but it's a Spring Boot app. Okay, so this is the component that I care about, and then the components with an S are all my dependencies. So in my case, I have the REST version includes a dice parser, but I'm also using Kotlin. So there's a bunch of other information, and remember I talked about the Perl, which is if I keep scrolling and scrolling and scrolling down through all these hashes, I can see the Perl here as well. And there's just, it keeps going. So I can look for Spring, if I can type Spring Boot test. So all my test dependencies are in here too. So if there was a problem with one of my test dependencies that maybe I ran the test during my build and there was some vulnerability in my test, that could potentially poison my whole build, right? So test dependencies are important. Now, if I have a container image already and I want to build an SBOM from that, I can install Sift. Everyone heard of Sift? A few folks. So Sift is kind of the de facto tool, I think, that most people are aware of if you want to generate an SBOM from a container. It's built into a lot of tools. Any sort of Docker registry probably has SBOM generation capability now, and they all kind of work the same way. So I'm going to output Cyclone DX JSON for this image. That's going to run. It's going to take a second, and it's going to be ugly. So let's reformat that. JQ. And then I'm going to pipe that to a file so I can open it in my IDE. And it should appear any minute. All right. And this is, oh, wow, that's a really long line. All right, so this is a very similar structured file. Again, we have the tool section. You know, it's Cyclone DX. 6.1 is the format that I'm using. This time it was created with Sift. And then again, we don't have any information about the hash that was used to create it. That's interesting. But again, I have the component. So this is my application. Now this time it's a Docker image. Right, so here's the image name and the version. and it has a bunch of properties associated with it, my Docker labels. All right, and then if I scroll down, I can see these are my dependencies, right? So a bunch of my jar dependencies show up, but I also have, because this is a Docker image, I also have things like base files. Oops. So that's an Ubuntu package, right? That's in the Docker image. So those things, if there's some vulnerability here, that would affect my application. There are no Spring Boot test. There are no test dependencies here because that was not in my container image. So there's nothing to find related to testing. So that's a potential problem. All right, let me switch back to my slides. Look at that, it worked, sort of. All right. So are we shipping jars to your product team? Or is anyone shipping images? Mostly shipping images? Yeah, so we don't ship jars anymore, mostly, but we did for years. So if I give you a jar, you want to know what's in the jar, or a war or an ear. But now we ship containers. So now I have to worry about my Java application, but also all of the other stuff that is in the container image. So typically, most of these scanners, as I mentioned, just kind of take an X-ray. They open up the container and they look to see what's inside of it. And hopefully they find everything. Sometimes they miss some things. They are smart now. They know if they find a jar, they should crack that jar open and look for the POM and get the Maven coordinates out of there. But, you know, again, I talked about a lot of the different tricks that we use to package Java applications. That could potentially trick one of these scanners too. Docker also provides SBOM generation at build time. So if you're doing multi-stage Docker builds, anyone doing multi-stage Docker builds? A few folks, yeah. Okay, so there's a lot of things in potentially your first stage of your Docker, your build, and then maybe you have almost nothing in your final stage, right? That's nice. It keeps your image nice and small. So if you care about your build time dependencies, you need to also scan that initial image. It's still using a scanning technique, so it's still, I wouldn't say 100% accurate, but it's still better than nothing, and there's a lot more context at build time. Yeah, so I already talked about this. There's a lot of accuracy issues with scanning, just the nature of scanning, right? You kind of scan through a file, oh, this looks like that. And it's kind of a best guess. But there's a lot of tricks we do with Docker images too, to reduce the size, to reduce your security footprint, so to speak, inside of the container. So unless you have that context at build time, you're going to miss a lot of potential problems. Anyone ever have this happen to them? No, me neither. Hopefully not. I always read stories about people who go in and get surgeries and like write an X on their leg, like not this one. Hopefully nobody gets scissors left in their cavity. But all these scanners kind of have a limited view, right? They just see what's there currently. So unless you're generating your SBOM at build time, you're not going to have that context. Build time provides a lot more information, right? So your Maven build knows exactly where your dependencies came from, right? Are you using an approved Maven repository that your IT department blessed, right? That information is only known at build time. After the fact, the info is gone. So my whole view is if you care about SBOMs, you need to generate them early at build time. All right, who here has worked retail? Ooh, only a couple of us? Really? Nobody else wants to admit it, right? I worked in a mall when malls were a thing. I don't know if malls are a thing over here anymore, but they're really not in the States. So every once in a while, we would close up the store and we would count every single thing that was in there. I've worked in a grocery store and a shoe store. So shoe stores have a bunch of shoes, but they also have t-shirts and whatever else, right? So you just go through the rack and you count everything and you stick a label on it. It's a major pain in the ass. So they do that usually to look for shrinkage or stolen products. So in my case, or in the case of my friend, if he had some list of SBOMs, right? He was looking for a log4j. His vendors all give him SBOMs. Great. He still needs a way to manage them, right? What are they going to do? Is he going to have like a Google Drive full of 1,000 different SBOMs and just kind of go through them one at a time, right? So on average, there are 50, 60 vulnerabilities released every day. No one's going to do that by hand, right? So you need some sort of tool to manage them for you, to have the inventory of SBOMs and do some scanning. There are a handful of commercial products out there. I don't know if there's any good open source projects that are doing the inventorying. If anyone knows of one, let me know and I'll stick it in here. But there's a whole bunch of commercial products that you can look at for this. All right. Alternatively, what I've done in the past also is essentially you query your Kubernetes cluster. So if you're managing Kubernetes, and you can just query everything that's running currently and then try to figure out an SBOM from there. If they're in the image or you have some index, you can go from the Docker image to your SBOM. And then, of course, if you find issues, hopefully you can act quickly on it. All right, who eats frozen pancakes? Who knew that was a thing? Right, okay, I didn't know it was a thing. I've eaten my fair share of Eggo waffles. But never pancakes. So pancakes, I think, are like the easiest thing to make at home. It's probably one of the first things you learn how to cook, at least in the States. But this is a prepackaged food, right? So there's essentially my SBOM. So this is my ingredients list. And I can tell right away that if I was vulnerable to wheat, milk, soy, or eggs, or I just chose not to eat them, I know to avoid this Eggo pancakes, right? It doesn't tell me anything about the factory that they were made in. Let's say, for instance, these are made on some factory, and there's some gears that are grinding, right? And metal flakes are getting into the food. Does this list help me with that? No, right? So they're not aligned. There's now metal flakes in my food. So is the ingredient list enough? The answer is no. So why do we keep talking about SBOMs as ingredients list when clearly that's not enough? You know, I'm not picking on Eggo, right? I don't know if they ever had any metal shaving issues. They have had recalls for like listeria and other things, which is frightening. But in both of those cases, we need something else besides just the ingredients list, right? So everyone know what we do? This is probably off some drug. But we have lot numbers. So I think in the EU and the US, we all have some sort of lot or batch numbers or codes that the manufacturers are required to stick on the boxes so they can make tracking these types of things easier. If they want to recall a product, they can say, hey, there's metal flakes or listeria in everything from, 58972 to 58978. Recall all of those. So in that case, are SBOMs enough? Anybody? Are SBOMs enough? It was in the talk title, if anyone's confused. So no, right? I don't think SBOMs are enough. We need to have that detail about the build time, right? So what if one of your CI agents was compromised? Are you going to trust anything that was built on that CI agent? No. That's potentially not in your SBOM. Right? So again, you're missing that build time context. And it's not just about your Maven build or your Gradle build. It's potentially your whole CI system, how that item flowed through your pipelines. Anyone used a CI plugin that had a vulnerability? A couple of us? The rest of us don't know it. Right? There are definitely vulnerabilities to everything you've ever used. So again, we really need to have the context of the build, right? Where I mentioned this already. Where were your dependencies downloaded from? What CI plugins were you using? What Maven plugins were you using? What if there was a bug in the compiler plugin, or an annotation processor, or something at test time? Again, I need that information to know if the thing that I built, the thing that I shipped in production, is vulnerable. I was picking on Docker images, kind of the weakness of scanning. But Spring Boot uses Paketo, the build packs. So the build pack folks are also creating SBOMs that they add automatically to the container. So I feel like that's the way that all of these tools need to work, right? This helps ensure accuracy, and all our build tools need to do these things at build time. All right, a couple more stories. Who's heard of the XZ utils or XZ utils attack? Almost everybody, right? So this was actually a social engineering, or it started with social engineering. I'm not going to get into that. That's fascinating all by itself. But essentially, someone was able to get commit access to a project, XZ utils, and they were able to inject an SSHD backdoor into the packaging of this library. Someone at Microsoft discovered it, kind of they were lucky. They were doing some performance profiling of a database, and they accidentally found it, which is mind-boggling how lucky we are that that person found it. But essentially, it was test data. This test data that was used and modified and put inside of the packaging bundle at build time. So there wasn't any malicious code in the product itself, but it was test data. So we learned some lessons here, right? So we need to start treating our tool chains, our CI pipelines, like production systems. If there's an issue there, that could affect my application. It could affect my production system. Single committer projects are obviously risky bets. Right? So if your company depends on a project, an open source project that has one committer, your company should probably get involved in that project. If not, you should find some other project. Attackers are always going to find the weakest point in the supply chain, right? And due to the complexity of all these things, almost nobody raised their hand when I asked if they used a vulnerable CI plugin. We don't even know about it, right? We're not even looking there. All right, next one. Anyone heard of this one? A couple months ago, Spotbugs had a key leak. Anybody? A couple folks, yeah. So this is a really interesting one. So in December, I think the key was leaked, and it was used in March, I think. Don't quote me on this timeline. But essentially, one of the developers of Spotbugs had a personal access token in a GitHub action. And through some other issues, that key was leaked. That was a personal access token that also had access to this repository ReviewDog action setup. So now the attacker has write access to this repository. And because it's GitHub and the way GitHub actions work, the attacker was able to replace a GitHub action tag with some malicious code. So anybody using ReviewDog action setup, potentially their whole pipeline was poisoned. And that's what happened to TJ actions. So this ESLint changed files. That plugin or that action was then compromised. And then, of course, anybody using that plugin or either of those action had basically fully compromised CI systems. And Coinbase was one of the people who were, let's say, affected by this. I think they were able to fix their issue in an hour or two, so their team had a pretty fast response. But essentially, if you used any of these, not Spotbugs, but anything below that, then your CI pipelines were compromised. Anybody using these actions? No, so you're all lucky. Yeah. So you're potentially all lucky. So there's some things we've learned here too. None of this stuff is new, right? These are not new lessons we learned. Even in the previous slide, we knew all these things. We just have to relearn them over and over again. So security is hard, right? It's just the nature of the beast. So we need to do better as an industry about making the secure thing the easy thing. But we also need to make sure we're reducing scopes of our tokens. So if you're using a CI token that has a wide spread of access, you need to reduce that down to the least privileged principle, right? So the minimal you need. Better yet, don't use personal access tokens in your CI builds, right? a lot of systems have some sort of like workload identity where you don't need to have a hard-coded key anymore. Your essentially CI system will authenticate, get a short-lived token, and with the correct scopes, and you don't need to do anything. You don't need to check in hard-coded credentials anymore. And remember, if you check in one of these things, right, nothing is more permanent than a temporary solution, right? So if you're working around an issue today, it's going to be there in 6 years from now, and that's when the vulnerability is going to bite you in the butt. Pin your GitHub actions. Who's using GitHub actions? Most of us? Handful of us? Yeah. So who is pinning all of their GitHub action SHAs? Not all of us, right? And there are some issues with this. Some plugins don't work right when they're pinned, or some actions don't work right. But for the most part, we need to start pinning to the SHA of the action, not using the tag for exactly this type of problem. I think this is a GitHub problem, though. I think GitHub needs to do a better job with that. It's a pain in the ass to deal with, right? If you open up your workflow file and you see a big long hash, like it's not really human readable, right? So it's a bit difficult to read. So I think GitHub needs to do a better job here. Releases and tags need to be immutable. So Maven Central, we solved this forever ago. If you upload something to Maven Central, it's read-only, right? There's no changing that thing. For exactly this reason. You could inject something malicious. You could have a build that works one day, not the next day. So versions, when they're released, are pinned, essentially. The one exception for Maven Central is if a malicious package gets uploaded, they will, of course, delete that. So that's good. All right, so I'm running out of time here, but what about the future? So what else do we need? Anyone heard of Providence? Few folks. Okay, so this is one of the things that's really coming to the forefront. In the art and legal world, it's the chain of custody of an item from basically origin all the way to its current owner. So who's owned it? So in the case of art, who created it? Who bought it? How was it moved to the next owner? Did it end up in a museum? That chain of custody all the way. The same case with legal evidence, right? Somehow that evidence was acquired. How did it end up in the court? If you can't prove that chain of custody, you can't prove that thing, that artifact is legit. And this applies to the software world, right? So we want to know when our software was created, how was it created, all the way until I deploy it. So I'm definitely running out of time here, but so I don't have time to get into this in too deep. I was going to bring up a J releaser example, but I'll let Andres do that later. So Salsa, anyone heard of Salsa? A couple people? So Salsa is really all about the provenance of your artifacts, or really it's supply chain level software artifacts, which is, I think, a terrible acronym. I always add the extra A because I want to eat some chips and salsa. But it's really a common vocabulary we can use to talk about supply chain security. So Salsa has multiple levels, and basically as you go up, the more secure your pipelines and your builds are. There's a checklist for each of these. So you're probably at level 1-ish today, and if you want to go up, these are the types of things you need to do to improve your security posture. All right, and we take Salsa, and we want to prove we did something, so we create an attestation. And that's basically a signed document in this in toto format that is a dead simple signing envelope. I'm going to run out of time, so I'm not going to show you one of these, but come up to me later and I'll do that. A dead simple signing envelope. Anyone ever heard of this? One person? Yeah. No. It's essentially like a JWT-like structure. It's JSON with encoded base64 encoded data that then gets signed. The signature is in the JSON, and that way you can verify the payload. Inside that payload is another JSON body that's, again, base64 encoded. And there's a subject, so that's the file. That's the thing that I built, right? So if I'm shipping a jar, I'm going to sign the jar. If it's a Docker image, I'm going to do that for a Docker image. And then I'm going to say, I have some fact to say about that. So there's some type of fact that I'm going to say. So Provenance might be my type. And then the fact itself, so a bunch of provenance information. All right, so I lied a little bit, so it's confession time. Cyclone DX, as of version 1.5, has support for provenance information under this formulation tag. And SPDX, as of last year, has a profile called SPDX build. So I lied a little bit, but I think my title is still accurate. Nobody, at least in the Java world, is making use of these, as far as I'm aware. So there's still no provenance information in SBOMs that we consume. And of course, if you're doing image scanning, you don't have that context anyway. So I still think it's valid. SBOMs are not really enough. All right. The good news, SBOMs, provenance, and any other build metadata that you can collect, or deployment metadata, CI metadata, all of those things, they all work better together, right? So beer and a burger. Many tools already support wrapping SBOMs in that in total format and signing it for you. So I think SIFT will do that, but most of the build tools will do this for you. And if they don't, there's other tools that you can use to wrap them and sign them, and basically saying this thing was approved. We built it on CI, and then you can then further in your pipeline you can trust, was this attestation or was this SBOM created in CI, and then I'm going to trust it. So once you start creating these things, so SBOMs, provenance docs, and other metadata, you can do all kinds of interesting things, right? So you can find artifacts that were built on a host that was compromised, or used a CI agent that was compromised, or a CI plugin that was compromised. But you could also write some policy, right? So you could use this data to write policy that maybe you're only going to use a certain compiler. Maybe you found an issue, a bug in a version of a compiler or a vendor, and you're going to write a policy that's not used. So if you record that at build time, you can make decisions at deployment time. And of course, you can do all this with historical audits too, right? So if I'm recording this stuff, I need a way to look back in time to see what was deployed that was vulnerable to log4shell or this ESLint issue. All right, so the path forward. So supply chains are complex, security is hard, right? So if you are not doing SBOMs today, I think the easiest thing is just start generating them. Even if you have to generate them from an image scanning tool, it's better than nothing. But if you're just generating your SBOMs and doing nothing with them, there's really no value there, right? Unless you're doing work with a government body and then you give them the SBOM and they say, okay, thank you, and they don't look at it either. But yeah, so start small, create them, look to see what other attestations your CI provider gives you. So GitHub out of the box has storage support for attestations. There's some basic attestations they will provide for you. There's GitLab, I think, does the same thing for anybody on GitLab. I haven't used that, but I'm pretty sure they do. So see what you get out of the box and start there. So I like to think about, you should attach those things to your artifacts. Either you can deploy them as Maven classifiers, as OCI attached artifacts, or you can store them in something like SigStore or some other attestation store as well. All right, so I'm definitely out of time. So if you want to scan this QR code, I have all the links to everything I talked about and the JReleaser example that I didn't get to as a link in there as well, and the link to all the slides and everything. But we are at time, so I'm going to move any questions out to the hallway. And so thanks, everyone. Oh, all right. All right, I lied. We have time for 2 questions. Oh. All right. All right. Which is better, Maven or Gradle? This came from Micah, I think. I mean, everything I build, I start with a Palm. So let's just say that. But Gradle signs my paychecks, so I'll just leave it that way. How do you validate that a deployed artifact matches the SBOM definition? Yeah, so that's a great question. So you need to use basically the SHA of your deployment. So the SHA of your deployment is, you can find it at deployment time. Like a Kubernetes container will say, this is the SHA of the thing that's running. And then you have to use that data to look up the SHA in your SBOM. And of course, if your SBOMs aren't signed, you can't trust your SBOM anyway. But that's how you match the two together. Or you attach the SBOM to the container itself. Oop. Oh, I got it. All right. Last question. Do bee stings hurt less the more you get over time? Yes. It's a very hesitant yes. It depends where you get stung. I still swear like a sailor when I get stung on my fingers. So that's it. All right. So if you have any other questions, or I can answer all these other ones out in the hallway, we have to make room for the next speaker. So I appreciate everyone coming. So thank you.